and welcome back to the Kids Corner portion of my channel, Learning Biology with Dr. Vanessa. If you haven't already checked it out, there's a whole playlist devoted to Kids Corner, which is the newest addition to my channel. In today's video, we are going to be taking a look at chemical reactions. Chemicals reactions occur in the body all the time, but you don't always see them. Today, we're going to do a couple of experiments so that you can actually see some chemical reactions. Sometimes in chemical reactions, things are made, sometimes they're broken apart, sometimes they even switch partners. We can't always see a result from a chemical reaction, but our body uses chemical reactions in things like breaking down the foods we eat. But for today, we're going to focus on some fun experiments so that you can actually see some chemical reactions. So what is a chemical reaction? A chemical reaction is when a chemical change occurs. And like I said before, sometimes we can see that visually and sometimes we can't. In today's experiments, you'll be able to see them. In a chemical reaction, you start with substances and then you have end substances. The substances that you start with are called reactants, and then the substances you end with are called the products. In order to know if a chemical reaction has occurred, look for things like vaporization, which means a gas has occurred, a color change, a temperature change, change in properties, does it become solid, does it become liquid, or precipitation. And precipitation is something that we can see in our test tube where you see a little bit of solid being made within your beaker or test tube. Today, we're going to be doing some chemical reaction experiments with the help of my lovely assistants. We'll be doing two different experiments, one elephant's toothpaste and another where we're going to blow up a balloon using a bottle. We'll be going through these experiments and the things you'll need for each of these experiments. And then at the end, stay tuned because we'll be going through a scientific explanation as to what happened during our experiments. So if you want to learn more about what's actually happening in the experiments, make sure that you stay to the explanation at the end. See you for elephant's toothpaste. All right, so we are going to start with elephant's toothpaste. The materials we are going to need are as follows. We will also put them in the description box below.
We need an empty plastic bottle, dry yeast, warm water, liquid dish soap, and 3% hydrogen peroxide.
3% hydrogen peroxide. This experiment will work with 3% hydrogen peroxide, which is found in your grocery store, your drugstore. We are going to actually use some hair product. This 30 Lift is actually 9% hydrogen peroxide. So we're going to get a little bit more of a reaction. 20 Lift is about 6% hydrogen peroxide, so you can use these. Now remember, this experiment is going to make a really cool reaction that looks like toothpaste, which would be enough for an elephant's toothbrush, which is why it's given the name elephant toothpaste. But you cannot eat the product that comes out of this, okay? So do not eat that. You do not want to do that. So you probably know hydrogen peroxide is something that your parents may put on your cuts when you get a cut. And then this is hydrogen peroxide as well, but it's a much higher percentage. You do not want to put this on your skin, but it is used to dye hair in a little bit higher percentage. Okay, and we need a couple more things for this too.
We also need measuring cups, measuring spoons, and large tub or tray to catch the foam.
We want to make sure that we have something to catch this with or do it outside.
And then food coloring.
This is optional so that you can get more of a dramatic effect. Okay, let's go ahead and start our experiment.
Measure 1/2 cup of hydrogen peroxide and carefully pour it into the bottle.
Okay.
Now you're gonna add a big squirt of dish soap into the bottle.
All right. Big squirt of dish soap into the bottle.
Okay.
Okay, that's probably more than a big squirt.
And then
nice. Swirl that gently to mix it.
Can
Good job. All right, what's next?
If you want to make your foam a single color, add a few drops of food coloring directly into the hydrogen peroxide and swirl the bottle gently to mix.
What color are we going to use?
I want to use red.
Let's do a couple drops of this. You want to put one? All right, awesome job. So we just added our food coloring into here. All right.
In a measuring cup, mix together 1 tablespoon of yeast and 3 tablespoons of warm water.
All right. 1 tablespoon. Let's get this yeast out of here. Would you like to hold that for me?
Yeah.
Please. Ooh,
I
there
thought
we
it was gonna be
go.
more powder.
Okay, pour that in there.
Wait, it's not open.
Right in here.
Mm-mm.
Right in there. And then you're going to scoop 3 of these and put them in there.
Oh,
3 full tablespoons. 1,
I can do it.
2. Okay, try to get a full one, okay?
Yeah.
It smells
3.
yummy, right?
It smells bad to me.
And then stir that for about 30 seconds.
30 seconds. We have a clump in our spoon.
We're gonna.
Oh no! We have a clump
Ew.
in our spoon. There we go. Get that out of there. A yeast clump. Science is messy. Okay. Well,
It smells like rotten corn.
yummy. Okay, now usually hydrogen peroxide, which we talked about before, breaks down. So hydrogen peroxide is H2O2, and I'll put that up so you can see it. And it breaks down over time into oxygen and water. But that takes a really long time, and it's also light sensitive. So that's why whenever you see hydrogen peroxide, it is in some sort of dark container so that that process happens very, very slowly. But yeast, the yeast that we're mixing right now, is going to catalyze that reaction. And if you know what a catalyst is, that means it speeds up the reaction. So that means instead of hydrogen peroxide taking a really long time to break down into oxygen and water, it's going to happen right before our eyes because of the yeast. So we're going to see what happens.
Ooh.
All right, you're going to tell us what we're going to do next. Mix them together.
All right. So now you're going to put it in the bottle.
All right, we are going to put it in the bottle. Is everybody ready for this? What do you guys think is going to happen when we put it in the bottle? Now remember, hydrogen peroxide is going to break down, I already kind of told you, it's going to break down faster into water and oxygen because of this yeast. So we are going to pour this slowly into this container. Is everybody ready to see what happens?
Yeah, can I say something?
Yeah.
You know, I put red in there, but it looks like a volcano.
Oh, volcano.
Yeah.
Are we ready?
Yeah.
Here we go. Let's see the magic happen.
Ooh.
Mix that up so that we can get all that yeast in with that hydrogen peroxide. Can you feel this? What does that feel?
It
What do you
feels
feel?
squishy.
Heat.
You feel heat.
Yeah.
Warmness, right? That's because this is an exothermic reaction, and so if you touch that bottle, you can actually feel heat. An exothermic reaction releases heat when the reactants come together. So look at that. We've got some nice
volcano.
elephant's toothpaste mixing with your red.
I think I know why
Look
they
at
call
that.
it elephant's toothpaste.
Now we didn't mix the red in at the beginning. Probably if we wanted to, we could mix the red in for a little more dramatic redness, right? So this reaction is taking that hydrogen peroxide that we put in, and it is actually making that hydrogen peroxide break down into water and oxygen much faster, which is creating this foam. So because the oxygen gets trapped inside of that hydrogen peroxide, it's pushing out this foam reaction, and you can feel, without touching that other side, I'll hold this, it's very warm, right? It's getting warmer as it goes, as the reaction happens. The bottle's actually getting pretty warm, okay? And so, yep, thank you. And so we have that warm reaction. So that's elephant's toothpaste. I'll write another explanation of that at the end of this so that we can explain that a little bit more, what's happening. And we're gonna go on to blowing up a balloon.
With the bottle.
In a bottle, using a bottle, okay? All right, stay tuned. The next experiment we're going to do is observing the formation of gas. For this experiment, you are going to need
A bottle, vinegar,
not the same bottle we just used, a new one, vinegar,
baking soda, a balloon,
we put the baking soda in a cup just to make it a little easier,
and a balloon.
and a balloon. Okay, so gather up your materials and we are going to work on this one. Oh. All right, let's go ahead and start. What are we gonna do first?
First, you want to put a couple of tablespoons in the balloon of baking soda.
A baking soda. 2 tablespoons of baking soda into our balloon. Now this is gonna be a little tricky. If you have a funnel, now would be a great time to use a funnel. We're just gonna try to throw this in here old school and eyeball it. Ooh, all over the place. This is why a funnel would be amazing. We're gonna put it in a little bit less at a time.
Can I try?
Put a little bit more and get it going in here. All right. Sounds good. Okay, we got a little bit of baking soda on the table, and we might have put a little bit more than 2 tablespoons. We are going to actually set this all up in here just in case we make more of a mess.
Now-
All right, what are we doing next?
Now you're gonna pour some vinegar into the bottle so it's about like half full.
Okay, half full. So let's see, where do you guys think is about half full? Probably right here-ish.
Yeah.
Let's pour that in till it's about half full.
That's gonna be hard.
Woo, here we go. Now. Okay, so we're putting white vinegar in our bottle. Okay, if you've ever done a bottle rocket, this is very similar to that. Okay, so our ingredients then, our reactants are vinegar, and what did we put in the balloon?
Baking soda.
Baking soda. So now what do we do?
We're gonna very carefully stretch the balloon around the top of the bottle, but make sure you keep the balloon down so that the baking soda doesn't fall into
Right,
the bottle.
so we
just yet.
don't want to mix the baking soda with the bottle content, right? So again, we have the vinegar in the bottle of in the bottom of our bottle, and we have the baking soda in our balloon. We haven't mixed them yet. What do you guys think is going to happen when we mix the baking soda with the vinegar? Take a guess as to what you think is going to happen. What do you think is going to happen?
It's gonna blow up.
You think it's going to blow up the balloon? What do you think is going to happen?
It's gonna mix with the vinegar and blow up the balloon.
Yeah, why? Why do you think that's going to happen? Anybody have a guess? Why is that going to happen? What are we going to form?
Air.
Air in the form of a gas, right? And that gas that's going to actually form is called carbon dioxide, the same gas that we exhale out of our bodies. So, what do?
So now you want to tip the balloon up to
Mhm.
allow the baking soda to drop into the bottle.
Okay, do we do any mixing?
And then you want to make sure you hold the top of the balloon
so that it doesn't fly away. So all at the top of the balloon, you want to dump those contents in. Here we go. Here we go. Oh, look at that. Look at that. Wow.
It's a little bit slower.
That's awesome. So that balloon is blowing up with carbon dioxide.
A little bit slow.
Look how cool. Yeah, the reaction's starting to die off, right? Because the products are all being used in there. But look at that balloon. Pretty cool way to blow up a balloon, right?
Yeah, you don't have to use your air.
So in this experiment, we formed a gas, and the reason we put the balloon on top is so that you could see it, because carbon dioxide, we cannot see carbon dioxide. And so you can see that something happened because the balloon was not inflated before, and now it is inflated. So something filled up that balloon, and that something is carbon dioxide. I hope that you enjoyed doing these experiments with me and my wonderful, lovely helpers today. I will stay tuned, because I am going to give you a further scientific explanation as to how these happen. I know I explained elephant's toothpaste a little bit more, but we're going to go into detail on elephant's toothpaste. We're going to go into detail on the chemical equation for this experiment too. And I'm going to ask you some more questions. So if you want to delve a little bit deeper into the science, stay tuned. All right, let's first talk about elephant's toothpaste. In elephant's toothpaste, we took hydrogen peroxide and mixed it with some yeast. Now, I already mentioned that hydrogen peroxide, H2O2, naturally breaks down into water, H2O, and oxygen, O2. Now, that process normally takes a very long time, and so we added yeast, which acts as a catalyst to help that reaction happen a lot faster, so you saw it happening right before your eyes. Remember what happened in the elephant's toothpaste? Think about it. When oxygen was formed, that gas got trapped into that hydrogen peroxide mixture, and we saw that foaming up. As that oxygen got trapped, we saw that foaming up, and it started to ooze out of the bottle, which is why we needed to have a container to catch it in. So yeast acts as a catalyst and helps that reaction happen faster. In your body, you have several different chemical reactions, hundreds of chemical reactions that are happening all over the place. But a lot of them happen while you're eating. And that happens in digestion so that we can use our food. And so there are a lot of enzymes in your body that allow reactions in your body to happen faster. Imagine eating and waiting for your food to naturally break down before you could actually use components of that food. You would be waiting forever. So enzymes in the body actually catalyze the reaction very similarly to what the yeast did in our elephant's toothpaste, and allow those reactions to happen faster so that you can digest the food that you eat. So think about that reaction too. When you did that reaction and you felt the bottle, what did it feel like? It was warm, right? That's because it's an exothermic reaction. An exothermic reaction releases heat as that reaction occurs, and so you could actually feel part of that chemical reaction by touching that bottle. Pretty cool, isn't it? Now let's take a look at the formation of gas. In the formation of gas, we had vinegar, which was acetic acid, and I'll put that up here for you to see. And we also had the baking soda, all right? And we'll look at the chemical equation for the baking soda. And one of the things that gets released from this reaction is carbon dioxide, CO2. And I mentioned before, carbon dioxide is the same thing that we breathe out. Well, carbon dioxide is a gas, and we normally can't see it, but when we did our experiment, we put that balloon on top, and what happened to that balloon? If you said that balloon started to inflate or blow up, you were right. So as we mixed that baking soda with that vinegar and created this reaction and carbon dioxide was produced, that gas was released from that reaction and it went into the balloon. If we kept the balloon off the bottle, we wouldn't really see the production of gas, even though it was there. So we put the balloon on the bottle so that you can see the gas actually being put into the balloon, and you saw that because the balloon blew up. And so that carbon dioxide was there in that balloon. Now, when you felt that bottle, what did it feel like? If you felt that bottle didn't feel any different than before. That's an endothermic reaction, and that's where the heat is being used in the reaction itself, and so you cannot feel it on the outside of that reaction. Something else to think about with that reaction is how long did it take place? Did you notice anything? Maybe it stopped when the baking soda ran out? So think about that and how long a reaction can actually occur when you're doing an experiment. Both experiments eventually stopped, right? So just think about that. Thank you so much for watching this video and participating along with us today. I hope that this really helped you understand some chemical reactions and what's going on in them. If you like this video, please make sure to give this video a like and subscribe to the channel. And perhaps we will make some more chemical reactions. There's so many different types of chemical reactions. We've kept it to 2 in this video. There are so many more that we can do that we can actually see different results from. Thank you.